Hello and welcome to Math200 Statistics here at Kenyatta College. My name is Ray Lapus, and in this video we will begin our lecture series with using this textbook from OpenStax Introductory Statistics. We're in chapter 1 and we're going to start with section 1.1. In this section, we will be defining some key terms in statistics and in probability, and then introducing ourselves to statistics in general. So statistics in general, as a subject, can be defined as a science of collecting and organizing and analyzing, interpreting data. Now that part is kind of like the descriptive part of statistics. And there's a second part, interpreting the data in order to make decisions. That part kind of bridges into the inferential part of statistics. So we can think of statistics as a descriptive part of statistics and an inferential part of statistics. And the bridge between them, we'll see, will be probability. So as an example of descriptive statistics, if we collected data from our class, say, and we asked what's the average amount of time in, say, in hours or nearest half an hour that you sleep per night. And so say we collected 5, 5.5, 6, etc. as our data set. With such a small amount of numbers, we can probably just graph this using what's called a dot plot. So nothing too fancy. We just draw a number line that would include the numbers that are in this data set. And for each number, we would put a dot above that number to describe how many students would sleep an average of 5 hours, for example, or 5.5 hours. We see that one student put 5, one student put 5.5, 3 students put 6, and 4 students put 6.5, etc. So this is a simple way to kind of visualize what's happening with your data set if you have a small amount of data, and this is called a dot plot. Now there are other ways to describe data sets. If your numbers get really large, you may be interested in breaking those up. And you might not just be collecting numbers either. So you might go to a couple of different colleges like Foothill and De Anza and ask how many students are full-time and how many students are part-time. And so we would tally those up and count them, and just putting numbers down might be a little bit tricky to see, but if you visualize it with a graph, especially if you're comparing a couple of colleges and what the full-time and part-time ratios are, we can take a look at these bar graphs, side-by-side bar graphs. Now the picture on the right is a pie chart, and so if you want to collectively collect a particular group of students, let's say in a statistics class, and we can count how many are freshmen, sophomore, juniors, and seniors, we can express those as bar graphs as well, but we can also put them in a pie chart to see and compare what percentage of them are freshmen, sophomore, junior, and senior. So with this, at one glance, you can quickly see that there's a lot more freshmen in a particular statistics class than sophomore, juniors, or seniors. Now, after collecting data, we can make inferences. So we can think about this particular plot. This is called a scatter plot with a regression line. It's something that we'll learn later on in a later chapter. But the dots would represent the data that you collect. And before we would draw the red line, we would look at the dots and say, hey, they kind of look like they're following a linear pattern of some sort. And so we would use our statistics information to be able to come up with this red line. And the red line would be the inference that we would conclude about this particular data set. And we can say that although the dots don't fall exactly in the line, in that particular line, it follows closely. And so we can use the line to make estimates or predictions about the inputs and outputs, the relationships between the x-axis and the y-axis. So the general goal of statistics in our class is not to get bogged down with the calculations of the numbers that we need to get, or even the graphs. We're going to rely quite a bit on technology, using calculators or computers, computer programs that would help us find the numbers, that would help us gather the information and sort them out. What's more important in this class is that when you come up with these numbers, to try to use those numbers to make predictions and make decisions about what it is you're studying. And so that's our main goal in statistics, is to get to the inferential part of statistics. Now, the bridge between descriptive statistics and inferential statistics would be probability. And the idea behind probability is to study the chances of things occurring in whatever it is that we're studying. And what happens there is that we're going to use the theories of probability to say, well, that was very likely to happen, so there's nothing really going on. Or we can say, oh, that wasn't likely to happen, and yet this thing occurred, and so there must be something special happening in this scenario. Here they gave an example of tossing a coin 4,000 times. So when you toss a coin 4,000 times, you should expect the heads to be about 50%. So you may not get exactly 2,000 heads and 2,000 tails, but if you get like 2,025 heads and then 1,975 tails, then it's not exactly 50%, but it's fairly close. So you can say, well, this seems like it's a regular coin. It seems like a fair coin, so it's a fair way of tossing. Nothing interesting is happening. But if you toss a coin 4,000 times and you get 1,000 heads and 3,000 tails, that's not even close to being 50%. So there must be something happening with your coin, or maybe with the way you're tossing it. Maybe somebody's figured out a way to toss a coin to make it come up to be whatever they wanted it to come up, and so that coin toss may not have been fair. And so if there's something happening, then we can use the ideas of probability to make conclusions in our statistics, to say, hey, it's not supposed to happen like this. And so this is the slide that talks about our statistics being based on probability. And so we're going to use the probability and the descriptive statistics to come up with our conclusions, our inferential statistics portion of things. All right, some key terms that we'll be using throughout the semester, so it'd be good to get them down, write them on an index card or whatever. Here we have a population. A population in statistics is something that you want to study, the whole group of things that you want to study. So we're going to use this example, and then we're going to use this example to identify the different key terms that we're collecting. So our example scenario would be, if you want to know the average or the mean amount of money that the first-year college students spend at San Jacinto College on school supplies that don't include books. So they randomly surveyed 100 first-year students at the college, and then 3 of those students spent 150, 200, 225, etc. Now, what is the population in this particular scenario? So the population would be all the first-year students that are attending SJC in the particular term that they're studying. So that's the whole population. Next term, our sample. A sample, to study the whole population might be unrealistic. So what we would do is we we would want to get a smaller portion or subset of the population, and so we would call that a sample. So the sample hopefully would be representative of everybody in the population. And that's where statistics kind of runs into some problems, and because there's some biases that might happen in the sample. So we'll study that later on. Back to our example about the average amount of money that the students spend on school supplies, not including books. We survey 100 first-year students at the college, so those 100 students that they're surveyed could be the sample. And whether that sample can be the first 100 students that they come up with, or they specifically select a few students from each class. The sample could be all the students enrolling in one particular section of a statistics course, which may or may not be a good representative of the whole population, but that could be your sample if we have 100 of those students. And it doesn't have to be 100, and finding the sample size is an exercise on its own that we'll see later on. A parameter is a number that describes the population. So it could be the average of the whole population, it could be something else, a standard deviation of the whole population. But whenever we refer to the mean of the population, that is the parameter. And chances are we probably won't know that because we would be studying a sample, and the mean of the sample is not a parameter, it's called something else. So a lot of times the parameters are going to be our unknown variables, and we'll just call them variables, and then we're going to find information about them. So back to our example, the parameter would be the average of all the first-year students. And again, we may not know this number because we're only going to be collecting a small set of data, a sample. Now, if the number that describes the population is a parameter, we need to define something that would describe a property of a sample. And that is called a statistic. Now, I know statistics as a subject is defined, or was defined, to be the science of collecting, organizing, analyzing data, and then coming up and drawing conclusions about that. So that is statistics as a subject. But in this class and everywhere else also, we will be using the word statistic as defined differently as well. And that would be describing a number that represents a property of a particular sample. So back to our example here, where we're talking about the amount of money that students spend on school supplies. The statistic would be collecting all those numbers and finding the average of the smaller sample of 100 students. So it's going to be the mean or the average of the amounts that were presented by the 100 students in our sample. So we're also going to be using the word variable. A variable will be denoted by, usually in algebra we think of variables as x or t or y or whatever. So in our case, we'll be using variables as well. We'll be using capital X and capital Y and maybe capital Z as well. But the idea here is that in algebra we say that the variable can usually represent one number. But in statistics, when we call something a variable, that could be a set of numbers. The whole data set. A variable can be represented, or can represent a whole set of numbers. Back to our example, when we have these numbers here, x can say represent the amount that's spent by the 100 students that we surveyed in our sample. So when we say x, x is not just equal to 100 or not just equal to 200, but x is actually equal to the whole set of those numbers. So 150, 200, 225, etc. And so you'll say x would just be this whole list of numbers of the 100 people that we surveyed. Now, when we collect data, we're going to be collecting data and then studying them. And so different types of data might yield different types of ways to study. And so we have to determine what kind of data we have. So numerical and categorical is a big interpretation of different types of data. So a numerical, or sometimes called quantitative variable, would be something that we would collect, and that would be a numerical value. So some examples here are pounds or times and hours, or the amount of money that you spend. Categorical data, or categorical variable, is sometimes called a qualitative variable, and that is something that's described as non-numerical. So it could be a person's gender or a person's party preference, etc. So we would call these things also based on variables. We call them x or y. So if we let x equal to the number of points earned by one math student at the end of the term, then x would be called a numerical data. And again, it's not just one number, it would be a whole string of numbers. And then y would be a person's party affiliation. Then y isn't just, say, Republican, Democrat, or Independent. Y would be a list of these labels, these categories, Republican, Democrat, or Independent. Now, I've been using the word data. So to formally define data, data would be the actual values of the variable. So we have a variable x, and whatever x could possibly equal to, or whatever x is equal to based on what we collected from our sample, then that list would be your data. So again, they could be qualitative or quantitative. They could be words or numbers, and just as another keyword here, datum is a single value. So back to our example, the amount of money that we're spending, that students are spending on school supplies. The data can be 150, 200, 225, etc. And again, these are quantitative variables because they are numbers. And then a qualitative variable would be if this first year student is whatever the gender of this first year student is, or whatever the party affiliation of this first year student. All right, so we have a lot of key terms to try to remember. We'll be using them throughout the semester, so you'll get used to using these words, but I encourage you to write them down and then try to commit them to memory earlier than later, so that we can get used to being able to talk about statistics. All right, that's it. Good luck.